question 19, back to some proof. Okay, so here you just identify like what the number meets what condition. So 175 is between 0 and 300, so it automatically equals 1999. And 375 is above 300, so you just plug 375 into this equation, which you get, which you get 93.75 for the 0.2 times 375. And then blah, 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 solve that. 301 is above 300, so you solve for that also, and you get 20.24. Here's the work. All right, for question 20, come on now. For question 20, it asks you to find the slope, which again, it's just the number in front of x, which is 1/5. And then the y-intercept, so plug in 0 for x, which is -6. And rate of change is the same thing as the slope, so it's 1/5. And then obviously you can see the graph here is increasing. All right, question 21. Question 21, this is a big one. Okay, so since the number, or since the leading coefficient is negative, it's automatically down. And the vertex formula is negative b over 2a. So you plug in -4 and -1 to get this. This work is here. And then to find you find the x-axis, plug the x-axis back into the negative x squared minus 4x, and you get y equals 4. And that's the vertex formula, or that's the vertex. And then the axis of symmetry is the same thing as the x value in your vertex that you just solved for. So the axis of symmetry is just -2. And then the x-intercepts you solve by the x-intercepts by factoring the main equation. As you can see here, I factored, which is -x plus 4, so it'd be 0 and -4, which are the roots. And then for the y-intercept, you set x equal to 0, and you solve it, and you just get y equals 0. And then you just have domain, -infinity to infinity. That's fine. And then the range is -infinity because it goes all the way down here and then stops at 4. And so when it's asking, I know, it's weird, but whenever it asks where it's increasing and where it's decreasing, it's asking for what x values it's increasing on, and what x values it's decreasing on. So it's increasing from -infinity to, well, what's our vertex at? Well, the x value is at -2, so it would be -2. Yes, it's increasing from -infinity to -2. And then it's decreasing from -2 to infinity because it's going from here to here. And on the x-axis, it's just here to here, which is infinity. So move on from that. Question 22. Here you just need to, it's another vertex formula problem. Whenever it asks to maximize or minimize something, it's asking for the vertex. So you just plug your numbers into the vertex formula, get -16,000 over -8, which is 2,000. So the x value, or the answer for this, is 2,000. Then you plug 2,000 back into the equation, and you get 16 million. All right, number 23. This is a larger question, I believe. So you also have to memorize this end behavior graph. If it's positive, or if it's even, yeah, you just have to look at that and whatever. So by looking at this, you can tell that it falls left and falls right. And then in order to find the x-intercepts, you have to factor. And you can see here. And the reason there's 2 zeros is because you square x. So it's technically x times x, so there's 2 zeros. Y-intercept, you set x to 0, and you just find the y-intercept at 0. And then the symmetry of the graph, as you can see, where's the graph? Oh, it's down here. So yeah, you can see it's like cut right down the middle, just by graphing it according to everything. I usually like to do the graph first and then answer this question, but do what you want. All right, question 24. It's just asking for the vertical asymptotes pretty much and the horizontal. So because there's this dotted line here at x equals -3 and x equals 3, the domain looks like this because it can't be -3 or 3. But there's no horizontal asymptote, so that means the range is all real numbers. Question 25. The vertical asymptotes are at 2 and -2 because the dotted lines are there, so it's that. And so this one's weird because the range is trippy. So there's a horizontal asymptote at 1, but there aren't any values between 0 and 1, so the range is going to be affected by that. And then all the values are below 0 or above 1. So that's how you show that it's greater or equal to 0, or sorry, it's less or equal to 0 or greater than 1. That's how you show it. All right, 26. 26 is the same thing. So the domain is, there's a vertical asymptote at -1, so you just say it can't be -1. And there's a horizontal asymptote at 3, so it can't be 3. And then to find the x-intercepts, you just, look at the graph, it's at 0, 0. So I just put 0, 0. And then horizontal asymptotes, it's at y equals 3. And then the vertical asymptote, it's at x equals -1. And then there are no obliques because there's no diagonal asymptote. Question number 27. This one, in order to find a horizontal asymptote from an equation, you have to follow 3 rules. You look at the degree of these things, of the leading terms, and they're both 1. So you have to look at which rule that meets. So the degrees are the same, so x equals y. So that you have to, the horizontal asymptote is the ratio of the leading coefficients. So it's 7 to 1, as you can see here. And that's just 7. It's basically 7 over 1, so it's just 7. If it were like 6 over 2, if this had 2 and this had 6, then it would just be 3, because it's 6 divided by 2. You see what I'm saying? All right, number 28, last question. If it loads. There we go. Okay. So here you just factor it. It's asking for, type your answer in factor form. So you just factor it. Easy enough. You know how to do that. And then the asymptotes, you find, how do you find them? Oh yeah, you just find them by doing the opposite of the roots. So x minus 4 and x plus 3. And the asymptotes are 4, -3. And then it's already in its lowest terms. You're never going to have to simplify it more because it's factored. And then the way you find the x-intercept is you set the equation equal to 0 and then solve, and I just multiplied both sides by the bottom to get rid of it. And then 0 equals x squared, and that's just 0. And then the y-intercept, you make x equal to 0, so you just solve the equation there, and it's 0 over -12, which is just 0. So the x and y-intercept is just 0, 0. The way you tell whether the graph will touch but not cross, or just cross, is you have to know the multiplicity of the intercepts. So in here, it's the multiplicity is 4 and -3, or that's the those are the roots. But there's a 0 multiplicity of the x-axis, or of the x-intercept. Like there's no 0 in here, in the bottom part. So the multiplicity would be 0, and 0 is technically an even number. And the rule is that if it's even, it'll touch but not cross, but if it's odd, it will cross. So if there was like an x in front of x minus 4, x plus 3, then the multiplicity would be 1, and it would cross the x-axis. And then it's asking for its vertical asymptotes, which you already know. It's already asking, or it's already asked that. And then it's always C. I just bet on C. For the horizontal asymptote, have you solved for that? Oh, that's right. You do the 3 steps again, like you did back here. So the degrees are the same, which means you do the ratio, and it's just 1 to 1. So that means the horizontal asymptote is just y equals 1. There's no oblique, just because there isn't. There never is. So the way you find out whether it intersects the horizontal or oblique asymptote is all you do is, let's see what I did. Oh yeah, you set the graph equal, or you set the equation equal to the horizontal asymptote, which was 1, as you can see here. You set it equal to 1, and then you just solve for it. So I multiply the bottom by the bottom part again, and so you just do algebra and find that x is -12, and you type in the ordered pair, which is x equals -12 and y is 1. And then here, the graph of r is above the x-axis. So from here, you should be able to graph. You should be able to know what the graph looks like. So that's why I do this one and then this, because you can just tell. So the graph is above the x-axis. Again, here, you use x values. So it's going to be -infinity. Here, let me zoom in on this. Uh-oh. Let me zoom in on this real quick. Okay, here you can see it's -infinity to 3, to -3. And then it's also above the x-axis from 4 to infinity. And then it's below the x-axis from -3 to 0, but like we answered before, it touches the graph, or it touches the 0. So it's not below or above the graph at 0, 0. So you just kind of skip over it. And then it's just 0 to 4. It's also below. And that's the whole thing.